Well, hello, welcome to the virtual tour of Spaceport America. I'm Chaz Miller, a spaceport engineer at Spaceport America. Hope your virtual Spaceport America Cup has been going well to date. Today, I wanted to talk a little bit about some orientation of what we do at the spaceport, where things are. I know many of you may have been here at the last Cup in 2019. And if you have, great. You may know some of these things already, but if you've never been here, it'll give you some orientation about where we are, why we're here, and what goes on here besides the Spaceport America Cup. On the side there in the chat area, you'll see that you can ask questions if you like during the session, and we can stop and talk. So I mean this to be a rather informal presentation. I have slides and I have a video. Video will take about 7 minutes, and the rest is me talking with slides, but I'm perfectly willing to stop talking if someone has a relevant question that takes us off on an interesting tangent, and we'll see where we end up. All right, so let me move on to our first slide then. So let's talk a little bit about where is Spaceport America. If you've never been here, if you've never been to the southwestern United States, it may be rather unfamiliar. So let me click on that. There we go. So Spaceport America is in the state of New Mexico. For people outside the United States, you may be familiar with what states there are, the 50 states. There are people in the United States who don't know New Mexico as a state. I came from the northeastern area of this country to move here, and some people thought I was moving to another country. They didn't realize that New Mexico meant New Mexico, which means it's a state. So an orientation on the map here from Google Earth. I have the outline of our New Mexico, state of New Mexico, and Arizona, an adjacent state to our west, just for reference. To the south and to the east is mostly Texas, so a very large state next to us. If we look on this map, in this white circle, this blue squiggly line that's hard to make out is the land of Spaceport America. So just give you an orientation. It's about in the south central area of New Mexico, not far from Interstate 25 passing along here, which follows the Rio Grande up through much of New Mexico, up through Albuquerque. Adjacent to us, to our east, is White Sands Missile Range. It's not a perfect rectangle, but I've shaped it like that. It's approximately the size and position of the missile range. And that's actually an important point. That's not a coincidence that we're right next to each other. So let's zoom in a little bit from this overview to take a little bit closer look at where Spaceport America is. So again, now we see the squiggly line. It's a little bit bigger. This is now in south central New Mexico. To give you an idea of where we are, we're somewhat remote. We don't have any major population centers right next to us. The closest town is Truth or Consequences, interestingly named Truth or Consequences, approximately 19 straight linear miles to our northwest. Takes about 45 minutes to drive there on a windy road. To our south, and a little bit to the east, is a bigger city, Las Cruces. I call it a city. It's over 100,000 people and over 250 people in the metropolitan area in the county. And so that's where most people who have offices or work at Spaceport may live, and actually have offices and drive and commute about an hour to get to the spaceport on paved roads. Just to give you some more orientation, we have a mountain range here, and the White Sands Missile Range base area is here. Army base is in this position here. The White Sands National Monument, if you come out here and you have a few extra days, we highly recommend you check this out. It's a unique area in the United States or in the world with gypsum, white gypsum sand. Very interesting material. And you can go out and walk around on these dunes if you have some time to go drive out here. And then the town of Alamogordo, famous for the first atomic test, although the test didn't happen anywhere near the town. It happened several miles north off of this map here. We are adjacent to White Sands Missile Range for good reason. We share their airspace. So as a Department of Defense area that have been testing missiles since 1946, V-2 rockets captured from Germany, this airspace above White Sands has been restricted. So commercial air flight does not occur almost any time over this area. So that makes being able to get permission from the FAA to launch into the altitudes where commercial liners go much easier because they don't have to redirect any traffic. So one of the key reasons for having Spaceport America where it is the fact that it's adjacent to White Sands Missile Range. If we take a look at some of the areas at Spaceport America, we have what we call the horizontal launch area. That area is where our runway is. It's 12,000 feet long, 200 feet wide. And that is where that's shared by many customers. Virgin Galactic, of course, has specified the dimensions for that so they can be able to take off and then glide back to a landing at Spaceport America. But various other companies and other kind of aircraft use this runway as well. It's not instrumented, it's not lit, so it's a daytime only airstrip. One of the iconic buildings here are what Virgin Galactic calls the gateway to space. We have a more boring term internally, the terminal hangar facility, because it's a terminal and it's a hangar. So that's what we call it. But it's known as the gateway to space, much more interesting marketing term. And this was built in 2009 to Virgin Galactic specifications so that they could house White Knight, two of them, and up to 5 spaceships. Now, all the work you see here has been paid for and developed by the state of New Mexico. Spaceport America is a state of New Mexico facility, in a unique situation where a spaceport is owned by a state. And so these buildings and the runway were built at taxpayer money. And we rent off these facilities to various customers. Virgin permanently is renting out this building. And of course, we knew they were going to be the ones that were using it. So they were the ones that specified key parameters and how it was designed, not just in looks, but in functionality, because the design really does match the functionality that they use. We also have the Spaceport Operations Center. That's used for a garage bay for our SAFE team, for fire and rescue vehicles, ambulance, fire trucks, brush trucks, and airstrip maintenance equipment. And we also have, at the moment, one north hangar, fabric hangar, and we have plans to expand on that. Another area that if you come to the Cup, if you've been here, you know about this. This is our vertical launch area. This is approximately 4.5 miles southeast of that runway. So if we go down here, we would see some all gravel roads. It's a little less developed, but there are some launch pads here, 10-meter diameter concrete pads. There's an area that SpaceX actually developed many years ago in anticipation of doing some Falcon 9 early testing, and then they actually never actually did it. So the infrastructure still exists. It now belongs to us, and we have the capability to use it as we wish. And then at the end of the long road in the lower southeast corner of the vertical launch area is a area where Up Aerospace operates, and I'll talk about that in a minute. So some of the pictures here, launch pads host various activities. Shown here is Exos Aerospace liquid fueled rocket. We have motor testing that goes on here to test solid rocket motors for Up Aerospace. This launch pad has been used not for launches that I'm aware of ever. Actually, it turns out it's 200 by 200 feet wide, can be, but it's been used for several companies doing rocket motor tests, liquid fueled rocket motor tests. So they've come in and temporarily used this nice open flat space to develop their development area. And then here we have a picture of Up Aerospace rail, and I'll talk about that a little bit more in some detail. So what I want to do now is I gave you a very general overview of the main areas of the spaceport. Now I want to do is stop sharing and show you a video that is nicely narrated that gives you some nice overviews, including drone footage of the history of why we got here and what and some of the prime areas of the spaceport. So what I'm going to do now is pull up a video, and let's take a look. Take this video, and this is about 6 minutes long.
The open skies and high plains of New Mexico have been home to the dreams of daring pioneers for thousands of years, and can be found along the New Mexico Space Trail, created by the New Mexico Museum of Space History in Alamogordo. The early peoples of New Mexico actively followed the stars, and several of these prehistoric solar and stellar observatory sites still remain nearby. Cultural artifacts and petroglyphs show their tracking of solar alignments, equinox, winter and summer solstice as early as 2,000 years ago. Back in the 1930s, Dr. Robert Goddard, known as the father of modern rocketry, launched a rocket that flew only 7 seconds, but reached 2,000 feet, traveling at 500 miles an hour, an earth-shattering event at that time. Building on Goddard's work, Wernher von Braun, the inventor of Germany's V-2 rocket, continued his developments in rocket propulsion and design in southern New Mexico after World War II. The race to space was on, as NASA began stretching its wings in the 1950s and 60s, with the U.S. Army White Sands Proving Ground being the test bed for most everything that America launched. But the boundaries being pushed didn't always mean going into space. Colonel John Paul Stapp of Holloman Air Force Base changed the perceptions of what was humanly possible by withstanding G-forces up to 35 Gs on a rocket sled. Colonel Joe Kittinger jumped from a helium balloon at an altitude of 102,000 feet and achieved supersonic speed traveling through the atmosphere before deploying his parachute, a world record that stood for decades until 2012, when Felix Baumgartner successfully jumped out of New Mexican skies from over 128,000 feet. That's 24 miles above the Earth's surface. Situated on a high desert plain, southern New Mexico provides perfect launch conditions with sunny, clear skies and the benefit of being 4,600 feet above sea level. So nearly the first mile up into space is free compared to coastal launch facilities. With plenty of dark sky locations across the state, New Mexico is also the home to many observatories, including the Very Large Array, Apache Point Observatory, and the National Solar Observatory. When scaled composite Spaceship One won the Ansari X Prize competition in 2004 in Mojave, California, a new wave of commercial spaceflight experimentation began. Southern New Mexico's exceptional launch conditions made it the ideal location for hosting the X Prize Cup from 2005 to 2008, with Armadillo Aerospace finally winning the competition in 2008, successfully completing NASA's Centennial Challenge. Now New Mexico is again at the forefront of space travel with Spaceport America.
Welcome to Spaceport America, the world's first purpose-built commercial spaceport. Spaceport America has been launching rockets since 2006. We've supported missions of all kinds of vehicles at our launch facilities since that time. These include high-altitude balloons, unmanned aerial vehicles, rockets, and spaceships. Construction on Spaceport America's most iconic building began in 2009. The Gateway to Space facility, the Spaceport Operations Center, also known as the SOC, was also constructed at the same time as the Gateway to Space facility. The SOC houses our SAFE team, staff officers, a STEM classroom, and our mission control. Spaceport America's runway, or Spaceway as we know it, is 12,000 feet long and 200 feet wide. The Spaceway is made up of 4 layers. The base layer is 18 inches of prepared subgrade soil, then 6 inches of cement soil mixture, 4 inches of asphalt, with 14 inches of Portland cement on top. Facilities at Spaceport America continue to develop and grow with our customers. Join us in southern New Mexico to experience the thrill of space for yourself. Book a tour from Truth or Consequences or Las Cruces and enjoy a ride in our G-Force machine. Visit spaceportamerica.com for further information. We look forward to welcoming you soon. Spaceport America, the space to be.
Very good view of as if you were here. It's the best we could do. It's much better than trying to travel from the VLA to the HLA each time. So let me pull up my talk now. And what I want to do next is go through some of the activities that go on. What are the customers who are here doing when we're not doing the Spaceport America Cup? So let me pull this up. Okay. And then, so what does it mean that the Spaceport America is owned by the state of New Mexico? It means precisely that the actual land and the people who work here as Spaceport America employees, including Alice and myself, work for the state of New Mexico. And that was originally all funded through state tax dollars. We now gain most of our revenue yearly through fees by working customers at the site. But the idea of the site is to not have us be a large contingent of workers, but to bring in many people from other companies to work at Spaceport, thinking of Spaceport as an operational center or a playground for various companies to be able to do their testing, to do research, and to do commercial operations at the Spaceport, sometimes all simultaneously. So because of that, we have a marketing department, and one of our prime goals is to talk to customers who are thinking of launching somewhere, flying. Sometimes it's a rocket launch, sometimes it's an unmanned aerial vehicle. And some of those customers come on temporarily because they have a rocket launch, like a university, say not during the Cup. But also we have what we call our tenants. These are more or less permanent companies who either have bought their own or developed their own infrastructure, but are here more or less on a regular or permanent basis. So there are 4 of those currently, and they are HAPS Mobile. I'll talk about them in a minute. Sorry. They're flying a craft called the Sun Glider, and I'll talk a bit about what that's about. Of course, Virgin Galactic, and they're the ones that are our anchor tenant. They're the reason that the spaceport got moving in the first place. And of course, they have the most well-known program, since it involves actually launching people into space. Up Aerospace is actually our very first customer, who was launching in 2006, 3 years before the construction of the runway even began. And then also Spin Launch, and I'll talk a little bit about their system. You probably haven't heard much about them in the news. That's how they want it at the moment. They haven't done any test flights, but soon we expect that may change. So let's start with Virgin Galactic. Now, I know Virgin Galactic presented yesterday on their successful test flights, and I don't have anything much to add to that. I do have some video that they produced of that flight if we want to see that later, if we have some time. But at the moment, I just want to mention who they are. Obviously, they are a company dedicated to doing suborbital flight, taking people and experiments on suborbital flights above 50 miles and operating out of Las Cruces. The ultimate goal is to launch first hundreds and then thousands of tourists, 4 to 6 at a time, on a flight to above 50 miles on a suborbital flight. I have superimposed on a Virgin Galactic graphic, which they may have already shown you, that shows their operational plan, which is to take the spaceship up on a ride on the White Knight to release it, have the rocket motor ignite for 60 seconds, reach apogee, and then glide to a reentry. So these are photos that were taken on May 22nd. So on May 22nd, 2021, Virgin Galactic successfully completed their first test flight out of New Mexico at their Spaceport America facility. They had done several glide tests and captive capture flights, but this was the first powered flight to space. Apogee was 55.4 miles, or about 89 kilometers. So these are all photos that we took during that time. Here's a White Knight on that day, taxiing down the runway ready for flight taking off. It's actually now flying in a viewpoint above the Spaceport Operations Center, the SOC building here. That's what this roof is here. This is a picture taken from the spaceport of that flight. They were about 19 miles north of us during ignition of their Unity spacecraft. And then this is actually an earlier glide test photo. I wasn't able to get a photo from here, from the test plane. So that's a Virgin Galactic photo of a previous glide test in New Mexico. But this was an actual picture of Unity landing on the runway on the day of that test flight. And you may have seen this video probably from the Virgin Galactic talk. They have a very nice video taken of that launch. This is one still, and I like to show it because it shows the rocket looking back to Earth right after the engine had stopped ignition. So I'm guessing they probably know better than I do, about 150,000 feet and climbing at this point, but no longer do you see the exhaust, but looking straight down practically. What we're seeing here is if you look for the outline of Spaceport America, here it is, north in that direction. You can see the runway right here, and the gateway to space is sticking off to the side there. And if you look straight down, we're looking at the Rio Grande, we're looking at I-25, and just peeking out along the top of the spaceship from this angle is the city, the town of Truth or Consequences right here, to give you an idea of where we're looking at. So this is the view that people looking out the window, flying out just as the engine cuts off, will see on their flights out of Spaceport America. All right, so I want to move from Virgin Galactic, and I'm happy to answer any questions that I can answer later if you have some questions about their flight plans and how they're doing their testing. But the next company I want to mention is Up Aerospace. I had mentioned, and as Alice had mentioned in the video, they actually started launching here in 2006. They are our first launch customer. And at the moment, they have the high altitude record for the highest altitude achieved from Spaceport America of 125 kilometers above the surface. So a little bit of information about their rocket. So they've got a single stage sounding rocket, and they run a whole business to launch payloads for profit. They launch a lot of NASA Flight Opportunities payloads. So a lot of Flight Opportunities programs utilize this vehicle as a vehicle for 3 to 4 minute zero gravity suborbital experimentation. And it's got a good track record. There's been 14 flights. The first one failed, and one other early flight did not achieve all its objectives. But since then, they've had a very good record of achieving flights usually above the Kármán line. Sometimes it's not the Kármán line because that's not the actual goal. But they've flown a lot of NASA payloads. They incorporate a Cesaroni aerospace solid motor, and that motor is cast here at Spaceport America at a facility at the vertical launch area. And as we can see in a picture here, they sometimes also then test their castings before using one of them in a launch. So about a month or so before they're going to launch, they'll be down here casting some motors and test firing one or two to make sure that that casting is good. We see it here on the rail. It's a 20-foot rocket. And as I mentioned, there have been 14 flights to date, up to 125 kilometers apogee. So comparing their engine, if you wish, to engines you may be using at Spaceport America Cup. If you take a look at Cesaroni Technology, the CTI's Pro 150 line of motors, looking at the most powerful, the highest total impulse O motor that I saw on their website today. We get a peak thrust of around 1,900 pounds for 5 seconds. And that gets you a total impulse of close to 41,000 Newton seconds. So in comparison, the Space Loft motor gets us over 4 times that peak thrust for 12.5 seconds. They don't quote a total impulse, but I made an estimate of it based on these numbers and some guesstimation, and it come out to about 400,000 Newton seconds, about 10 times an O motor. So imagine strapping 10 O motors together, and you've got this vehicle. What that can do then is move a vehicle that is up to 780 pounds with a full payload. Payload could be up to 80 pounds of that, up to an altitude of 77 miles, potentially higher. The rocket itself is about 20 feet long and 10 inches in diameter, just to give you an idea of comparing it to the rockets that you're making, but very similar in concept in any other way. If you go to the Up Aerospace webpage, if you're interested in flying on here, you could pay to have a payload flown on any of the Up Aerospace upcoming missions. Usually they'll end up flying when they get a full manifest. So that kind of drives how often they fly. If they have customers and they have a full manifest of payloads, you can fly. So on the right-hand side here, you'll see in their payload users guide, which you can find here There are downloads of that at this website. Just go to Up Aerospace and follow the links if you like. They have a diagram of their payloads. The nose cone has various sections, and they have all the dimensions there for that. This part of the rocket does not get exposed to space, and these areas down here do. So depending on what you need to do for your payload, you may be exposed to space or not. They provide all the data that you need to get an idea of your payload mass versus apogee if you're the only payload. So obviously less mass. If they don't go to the limit, they can get a higher altitude and longer time in microgravity. And then also on their payload user's guide, you can get an idea of the lateral axial thrust G-forces and how they change over time, maxing out at about 15 Gs, as you would expect on a solid motor vehicle. Also, there's an interesting flight video that's a GoPro video. Actually, the Up Aerospace won a GoPro award for a flight in 2010. So there's a very interesting video. If you search for Up Aerospace GoPro, you'll probably find this video on YouTube. And it's actually a very good video showing you all aspects of that. That picture I showed earlier of the rocket here comes from that video. So you can actually see the separation of the rocket motor and that payload section that can be exposed to space. And of course, this is returned by parachute, but you can actually see this whole thing separating just by chance in that video. So it's really cool. You can check it out. So another customer, so that's one of our, so that's the second of our main tenants, 4 main tenants. The third is Air Environment. They have been on site since early 2020, and they have an interesting aeronautical history going back to Paul McCready. They were the company that developed some innovative, very lightweight vehicles, starting with the Gossamer Condor, in an attempt to try to win the Kremer Prize, which was precursor to the X Prize, a different organization that offered that prize in the 70s, for the first human-powered flight to travel over a obstacle course, essentially an eight-shaped course, I think running over at least a mile. So they had to make some turns, they had to show maneuverability, and they had to show sustained flight for enough time, powered by a person pedaling the propeller. And they successfully did that in 1977. They followed that up with another prize that was offered to cross the English Channel in a human-powered vehicle only. And for that, they designed the Gossamer Albatross, which won that prize in 1979. They also have a history of other innovative vehicles. Helios, which you'll see is very similar to the Sunglider in concept, certainly. It's a solar-powered craft, multiple engines, weight is distributed along the wing. And that interesting wing shape is actually something they learned in the process. There's a very interesting video on the Albatross where they learned that a flex in that wing actually helps in roll stability quite significantly. Without it, a very long wing like this tends to want to tip. And once it does, they lose control. But they found that this sort of smiley face shape is, first of all, nice because it means a lighter craft. It doesn't have to be so rigid. But this flex that is induced by the loads all along the wing after it takes off helps it keep stable while it's in the air. So that leads us to 2020, the Sunglider. I'll tell a little bit more about some of the dimensions. Quickly, I'll just mention it's 260 feet across to give you an idea. 10 propellers. And the concept of this, Air Environment is one company in a consortium of companies led by HAPS-Mobile, whose plan is to have these craft flying overhead with a base station for 5G or cell service being developed by Loon. And that craft, while in the air, in the stratosphere, above normal flights at 60, 70,000 feet, will provide a cell tower, essentially, that's 200 kilometers across for the ground with very low latency compared to satellites, because obviously it's closer to the ground. So light travel time back and forth is much faster than even low Earth orbit satellites. So that's the concept. Test this. It can fly in the air for 30, 60, 90 days once up there on solar power and then batteries at night and never come down and run autonomously. So let's think about this a little bit. How do you fly a plane just on solar panels? So I did some back of the envelope calculations. This has not come from Air Environment. I did not have Air Environment check me on this to see if this is correct, but I did it as an exercise once for some students. I think it sort of illustrates, if you want to think about it, how much you need to get out of all your equipment to be able to operate in this kind of environment. So as I mentioned, it's a solar and battery powered flight. So it runs on solar power during the day. That solar panel excess power that isn't using to turn the propellers or run the base equipment, which is the key payload, goes into keeping the batteries charged. And then at night, the batteries take over and keep it in the air. This particular craft has an 80-meter wingspan. And this is my guess, because I actually haven't seen this quoted anywhere, but I guess maybe just looking at some photos, about 10 feet. I could be wrong about that. About 3 meters in this dimension here. So let's think about that. How much solar power could you get out of that? If we're trying to calculate solar power at Earth, there's a variable called the solar constant. It's actually the amount of power available at the top of the Earth's atmosphere based on the luminosity of the sun. So this is a number that's a factor of the sun's luminosity, which is fairly constant, but also your distance from the sun, which the Earth is at a certain distance. Planet further away has a lower solar constant. Planets closer have a higher solar constant. That number happens to be 1370 watts per square meter. So every square meter on the Earth, if the sun's directly overhead and there's nothing attenuating the sun through the atmosphere, you get about 1.37 kilowatts available to you in some way if you have a way to convert that. So let's see how that would translate to power in this case. If we look at the others of the possible area, and it does look like every square inch of this wing on the top is covered in solar panels, that would give us about, just multiply the rectangle together, about 240 square meters. If you multiply those two numbers together, you get 328 kilowatts. However, and that's if the sun's directly overhead. There's a cosine function as the sun is at different angles during the day. That reduces significantly by the cosine of that angle. It's maximized, of course, when it's directly overhead. However, solar panels are not 100% converter of solar power. In fact, a good one is maybe 20%. It's obviously a key issue in research, is to try to increase that so you get more power given the same area. But for right now, I don't know exactly what that number is on AeroVironment's plane. So I threw that out there. Could be 20, could be a little bit higher potentially. But of course, they have to go and trade off lightness with efficiency at the same time. They've got several trade-offs there. So if you multiply that 20%, get down to 65 kilowatts. And remember, there's 10 motors, 10 electric motors for the propellers. That works out to be about 6 kilowatts per motor. And if you work it out, if you feel more comfortable in horsepower, like for a car, it's a little under 9 horsepower. So you got 10 9-horsepower propellers keeping this thing in the air all the time. So a lot of careful engineering goes into keeping this aloft, keeping the energy balance correct to make sure there's enough power for the propellers, enough to charge the batteries, enough for the equipment, which is what the craft is up there for in the first place. So the picture here we have is a successful flight up to 62,500 feet, and more tests are planned to keep improving this platform. Then once this platform's perfected, it could be mass produced. And again, this could produce a series of 200-kilometer diameter cells, essentially, from a craft that is overhead, circling over the same spot for months at a time. All right, so that's a third application of aerospace engineering that's occurring at the spaceport. Let's end here with the fourth, and this is spin launch. So now, again, all of the things I'm going to show you now are my own back of the envelope calculations. Spin launch has not endorsed this. They haven't provided this information. Everything I'm showing you is something you could deduce from what spin launch has put out there, but a lot of this is my own deduction. So what is the concept of spin launch? The concept of spin launch is what they call a kinetic launch system. What does that mean? It means gaining a kinetic hypersonic launch system. So the idea is to gain hypersonic velocity of a capsule, of a craft, at the ground and let it fly unpowered up above the atmosphere. So, and to do this, in their case, they're going to do it electrically. So they're going to project an object to 3,500 to 5,000 miles per hour. 3,500 is just under Mach 5, so just under hypersonic, up to above Mach 5 hypersonic territory, and do that via electric motors. So picture, now I have a photo here, and pretend you don't notice that maybe it was taken at a famous company's resort area. I've tried to block them out a little bit, but I wanted to get a picture of a Ferris wheel about 120 feet high. Turns out this particular Ferris wheel is 150 feet high, so not good enough for a photo. So this is not spin launch. They do not have a roller coaster nearby. This is not a theme park, but I want to use this as an example of a concept. So imagine a 120-foot diameter wheel spinning fast enough so that the cars are traveling, I say at the minimum, 3,500 miles an hour before you release them. That's what Spin Launch is planning to do. So if we work that out, what we're really doing is we have an arm that will be traveling rapidly enough that at the end of that lever arm of 60 feet long, we're traveling at this speed of 3,500 miles an hour, the lower level. That translates to 5,133 feet per second. Now, to do that, and I didn't include this in here, I leave this as an exercise to the student, what would be the dynamic pressure on an object at the bottom of the atmosphere, even at 4,600 feet, where Spaceport America is, when it leaves a system like this? And it's pretty significant. You can calculate out, you have to get an idea of what the size of the object is and what its coefficient of drag is. And I've done some back of the envelope calculations I didn't show here, but it's significant. So of course, how do you get to that speed then in the atmosphere? And the answer is, Spin Launch's solution is you will enclose this entire area in a vacuum chamber. So what they're building is a large, I'll call it a tuna can sitting on edge, that it would enclose something like the size of a large Ferris wheel completely, that they can evacuate from air. So during the hour it takes to spin this up to speed, it is not facing any wind resistance at all. When it releases the object, it will certainly encounter wind resistance. And I'll talk a little bit about whether that's insane or not. And the answer is no, people have actually done something like this in a different application. Well, let's do a few back of the envelope calculations based on this. So based on this concept, how fast does it have to spin to do that? So if we look at the period of rotation, assuming the velocity of 3,500 miles an hour, we get one rotation in about 73 milliseconds. And what does that mean? That works out to a rotation rate of about 1 every 13.6 revolutions per second, almost 14 revolutions per second, which is 85 radians per second. You get about a degree every 200 microseconds. That gives you an idea of how precisely they'll have to release this object if they want to get, say, a degree of precision in their release angle, in their launch angle. They would have to release within 200 microseconds. If they want more precision, they'll have to have a better precision on the release time than that. And that all translates to about 800 RPM. And when you think about 800 RPM, that isn't that fast. If you look at your red line on your car, it's several thousand RPM. Your car idles usually at maybe 1,000 or 1,500 RPM. So this isn't an insanely fast speed for, say, a motor. It's only a lot of speed because you're going to have a very large lever arm with the capsule at the end of it. So that's the application. So they can actually use some fairly common industrial objects to be able to get this up to speed electrically and spin it. Of course, the rest of the engineering to release it, to go into the atmosphere, and to control all that is what's unique about Spin Launch. So that seems fast. Won't there be a lot of acceleration? Sure, there will be. So if you calculate the centripetal acceleration at the end of this arm while it's spinning at 14 revolutions a second, at v squared over r, you get about 439,000 feet per second squared, divide by 32, Earth's gravity at 32 feet per second squared, you get about 13,700 Gs. So obviously this is never going to be a human-tended capsule. This is tended only for hardened electronics, things that can survive very high G forces. And in fact, if you go to 5,000 miles an hour, you can do that calculation and calculate how many Gs that would be. I'll leave that as an exercise to the student as well, but it would be obviously higher. So the concept then is at Spaceport America, the idea is to test this system out suborbitally for the first flights. And that'll be a significant milestone to achieve that. So the idea is here we have the system not to scale in this case, but spinning around, flinging an object probably about the size of a gas cylinder-ish, is kind of the size they're talking about. Not that shape, but that kind of size perhaps. And at the proper angle so that it can reach the Kármán line, maybe higher in later tests when they get the faster speeds, and then drop back down about 15 miles downrange, which is capable of being done at Spaceport America. And so there's a whole range of these tests to test out the system. Eventually, they want to build a bigger system than this, larger than 120 feet in diameter, at the coast to be able to launch an object here and then have a second stage rocket provide impetus to get it up to orbital speed. So this would be, if while working, a cheap way to achieve orbital flight for objects that can be hardened to high G-forces. So is this totally crazy? Well, no. There's actually a program in the 60s called the High Altitude Research Program, or HARP, done by a Canadian team. And they produced objects, capsules with hardened electronics called the Martlet series. In this particular case, you can look up online, Martlet 2 flights. They had 200 flights over a span in the mid-60s. They were launching an 84-kilogram object, and they actually achieved an apogee of 180 kilometers. They achieved a very high apogee many, many times, but their maximum was 180 kilometers. Their firing speeds were about the range we're talking about. They were going 4,500 to 7,000 feet per second. They had accelerations of 15,000 Gs to fire this out of this gun over here. And of course, we can see some of their progression of objects here with somebody hopefully standing there with a gigantic ruler. So this is something that was actually done, tested. It was not funded any further and didn't go anywhere. But the concept here is to not fire anything. There'll be no explosives. It will be to spin an object up and then let it go. But the same idea, you'll be moving at hypersonic velocities right out of the gun, right up into space. So you can take a look at for more details if you want at this website here at Astronautics to get more information about that program. And so those are the four main tenets. What we often get are a whole bunch of other activities that are going on that are more limited duration. Someone may come in, it may be just for the weekend, it may be for a couple weeks, and they may come intermittently, but they are a presence that we support on a case-by-case basis. So we have at the vertical launch area, university and commercial launches, for instance, besides up aerospace. We've had balloon launch for the Boeing Starliner parachute testing. We've had unmanned aerial vehicle testing. Most recently, a company called Stratodynamics, which was a consortium including University of Kentucky and NASA Langley. And they launched a balloon-launched UAV to 30 kilometers and then dropped it, and it autonomously flew back to Spaceport America over about 4 hours. And the idea of that was to test turbulence in the stratosphere. So it was a test case. It wasn't to test the craft itself, but using the craft as a research platform to test turbulence in the upper atmosphere. And as you've seen in the video, we've had rocket testing. Here's Cesaroni solid rocket testing. Here's a company called C6 Launch. It was testing a liquid engine at Spaceport America. So a whole bunch of these things continue to be done here. And maybe someone here at Spaceport America Cup will be coming back on some of these programs. So we're nearly at the end of our talk here. I had an altitude chart here just to summarize where to scale all these things are going on at Spaceport America. So you can get an idea of where the Cup launches are at this scale. Say we have Mount Everest here, passenger jets at 35,000 feet, White Knight 2 releases, Unity at 50,000 feet, which then boosts, cuts off around 150,000 feet with the motor, with the solid motor or the hybrid motor, and then coats up to their highest test in Mojave was 56 miles. Their latest test in New Mexico is 55. Up airspace has reached, as we mentioned, 77 miles. Spin launch hopes to reach the Kármán line or higher with their kinetic launch system. So, and if you were to actually figure out, and I'm sure people here in this audience can do this, if I use this to talk to people when they ask how far away is space, and they think it's enormous distances away. But if you actually were driving on the ground from Las Cruces along I-25 through Doñana exit, hatch, you go to Spaceport America or go to Truth or Consequences. If you're going straight up, you'd be heading to space and reaching the altitudes that many of these craft are reaching. So it's a good eye opener for a lot of people to understand their atmosphere, which sort of cuts off. There's hardly any of it left at 100,000 feet. Just above that, we're at the air pressure at the surface of Mars, and it just keeps getting thinner. It's not that far away. And this is what's going on at Spaceport America. So that brings me to the conclusion, and I'm certainly open to any questions here that anyone might have.
You've got a couple, Chaz, so I've answered one of them, but I think it's worth us reading out loud. It says, Do these companies exhibit when the teams are at Spaceport America?
And the answer is it depends. So many of them do not. They have their own reasons. They're doing research. Research can go wrong. They don't necessarily want crowds watching it. They certainly may invite their own guests. So if you know somebody at these companies, you could talk to them. They'll bring investors, they'll bring supporters, they'll bring people that are helping them. But a lot of times they don't want us to say anything. And we do honor that agreement with them. Of course, that's one of the reasons they're coming out to Spaceport America.
Well, that is a caveat to that Virgin Galactic have been a sponsor at Spaceport America since 2017, and they are always exhibiting during the Spaceport America Cup. And I also meant to mention that Air Environment have sponsored teams that have competed at the Cup as well. So two of our tenants are quite heavily involved, and we are hoping once Spin Launch start to get more active that they will get more involved as well in the Cup going.
Okay, I may have misinterpreted the question. I thought that meant do they want their launches,
no. I think they were thinking more about involvement.
Giving us money. Okay, well, that's more, okay, and Alice knows exactly what's going on with that. So yeah, I didn't mean to, so I was answering a totally different question there. But if you ask the question of, because a lot of people do ask, can I come out and watch these launches? These look really cool. And that's a very logical question, especially for people in the state of New Mexico whose taxes have paid for this. And a lot of times we can't offer that. The customers actually don't want it. And of course, some of these activities are unsafe unless you're far away. So only launch personnel are on site when a lot of these things are going on.
The next question from Julian Chi says, are there local rocketry clubs that organize fun fly events for Rocketeers at Spaceport America?
We have not done that recently. I know there are organizations that do have open sky days, and we're talking about doing that because we now have entered an agreement with Ezra and Tripoli. We want to become, establish a prefecture at Spaceport America. So there's nothing that stops us from doing that. We simply have to make a proposal to the FAA to get a weekend or something, which we do, which other flight customers do on their own routinely. But the answer right now is we don't have that. Keep asking us that question, because the reason we haven't done it is we just haven't had the time to organize that. But it's a good idea to do that sometime. There are local rocket clubs. Flare, there's an organization called Flare locally, and on the top of my head I will not remember their acronym, so I don't want to mess it up. They do support a lot of launches. They do go to a lot of the places that do have free flights to certain altitudes. They do have rails, and they've been on our site a couple times too to support other universities who are coming out and need some support like that from an organization. So there are organizations. We do have some local universities in New Mexico that have their own, are obviously in the Cup, so they're also launching. So that's what that is.
I think that covers it all. Next question is, how far in advance does an RFP for field use need to be submitted to Spaceport America?
So I guess you're talking about an RFP, and I think of it as something else, and we're doing infrastructure development, which is a totally different thing. It takes a long time for us to build something here based on state things. But I think what you're asking for is, like, if you wanted to call us and say, I want to fly out of Spaceport America, how far in advance do you need to do that? Because the process is somewhat informal in the beginning. You can just send us an email and we'll tell you what you need to do. We'll give you some questionnaires. We'll talk to you about what you're going to do, and we'll answer that question. So sometimes the answer is depends. A lot of times, like say university wants to come out and launch, and many do. The real gating item, we have to talk with White Sands Missile Range. We coordinate airspace with them. But more importantly, you will have to contact the FAA and get a waiver. If your rocket is of the class that needs a waiver. If it needs a license, it's a bigger rocket, then you have to go through that process, which is longer. But you have to go to the FAA, which is at least 45 days. We would usually require a little bit longer for a coordination White Sands, a couple months. Let's say 3 months would be a good amount of time to know ahead of time. So let's say you were thinking of launching next spring. It would be good to talk to us, right at the beginning of the year, and go through your operations. Now, if it involves something much more sophisticated and a larger operation, that depends. So I'd say there's no fixed time. I'd say 3 months. Yeah, you can't call us up and say, I want to launch in 2 weeks. Usually that's impossible, just in a regulation sense. But even if the FAA said, okay, and we don't know about it, we do have to do some coordination here and get our staff set up, and also deconflict with anything else that's going on, say like a Virgin flight or one of the other customers' flights. Good question though. Yeah, so 120 days out. So somebody say 120. So come to us. before you don't even have to have gone to the FAA yet. And a lot of times people do come to us and we have to tell them they have to go to the FAA. So that's part of the process. But yeah, come to us a little ahead of time than just doing the FAA request. And certainly don't come after you've gone to the FAA. You pretty much can't, because you do have to give them information about our spaceport, where you're launching from, and all of that anyway. So yeah, so I think that's a reasonable thing, 120 days out. If you're going to do a rocket launch like at the Cup, which is a very standard thing to do. If you want to go to the Kármán line, we have to talk a little bit about that, because White Sands, we'll get more involved in it. That means you could reach White Sands and their facilities if something goes wrong. So they will have safety reviews. So at least 120 days for something like that at the minimum, because they take their own time. We'll put it on the docket, but we don't control when they actually look at it, or what they may say. If they may say, I want a transponder on that thing, or I want you to add, improve your avionics for flight termination or something like that. A good question, though. All right.
I don't know that we've got any more questions to answer. We'll give them another 30 seconds. If not, we will close this one down, because we've then got Dan Kruger from the Kansas City National Security Campus, who's going to be doing the talk about what it is that they do with Honeywell over there, starting at 2:00. So I'm filling time to make sure if anybody has any last questions, they can put them into the chat. But if not, I wanted to say a big thank you on behalf of Chaz and I and all the staff at Spaceport America for everything the last few days. We've really enjoyed talking to all the students that have come to our booth space and to our lounge and have asked some fantastic questions. And we will be here again tomorrow morning between 9 and 10 a.m. Central to be able to answer your questions. We're going to hang around this afternoon to join you for the social mixer as well, which I thought was the most fun thing we did yesterday, which will be at 4:00 Central Time. So if you're around at that point, do join us. It's a lot of fun. It's like speed dating for Rocketry. And also there will be the award ceremony tomorrow. We will have our executive director giving out the Spaceport America Cup Award. So do make sure you tune in for that. And thank you for all the questions about recordings. We will make sure that they're successful for 2 weeks after the event is all closing. And on that, I think I'm going to say thank you very much.
Well, thanks everybody for coming. Hope you learned something or found something interesting. And if you have that generates any discussions with us, feel free to email us and ask more about it. Thanks a lot.
Thanks, guys.